CalAdapt is a product of the California Energy Commission and the Natural Resources Agency and has been developed by UC Berkeley's Geospatial Innovation Facility to help bridge the gap between the wealth of climate change research and data being produced by California's scientific community and those who need reliable, easy access to support planning and adaptation efforts. When you arrive to the site, you'll see that there are a variety of different climate tools that highlight different topics like temperature, snowpack, precipitation, sea level rise, and wildfire risk. I'll step through a few of these with you here to show you some of the features available on the site. If you visit the local climate snapshot tool, this is the easiest way to get very fast access to quick local information for any location in the state. Simply click on the map or enter a location in the search bar to find historic average temperature, a low emission scenario future temperature projection, and a high emission scenario future temperature projection for this particular location. You'll also see a chart that shows from 1950 through 2099 what these two different scenarios will look like. And you can click anywhere in the state to find this information. You can also choose the snowpack, which will show you the projected historic average snowpack versus a low emission and high emission scenario percent change over time. For the coastal regions, you can choose to see sea level rise, which will give you a county average for the amount of land vulnerable to a 100-year flood event, both currently and after a 1.4 meter sea level rise projection. Lastly, in this tool, wildfire risk can be chosen to look at the fire risk relative to 2010 levels in 2020, 2050, and 2085. The climate tools are also available below each tool here, and I'll step through a few of those. If you look at the decadal averages map, what you're presented with is the average annual temperature across the state, and you can use this slider bar to go between 1950 and 2099 and visually see how the average annual temperature is projected to change. You can also click anywhere on the map and be presented with a chart showing the A2 and B1 high emission and low emission scenarios for this particular location. Digging deeper, there are a lot more options available. If you wanted to look at an individual month instead of an average annual, you can choose the month here. You can choose a particular scientific model rather than the average of all scientific models available. And you could choose the temperature lows, averages, or highs. For each of the tools that are available on the site, there's more information about the data sources, where the data came from, and links to any reports related to the data and calculations that have been done to present the data on the site. And there's also the ability to share the data through a dynamic URL, which will capture all of the settings and locations that you've entered, so that when you share that link with someone else, they'll be able to see what you were seeing. And more information is found below, including some related stories. In the degrees of change map, what you'll see is rather than looking at temperature over time, you see the time period based on the beginning of our study time, 1961 through 1990, a baseline temperature, versus the end of century, 2070 through 2099, and those are subtracted to show the degrees of change that are projected to occur. And as you see, it is not distributed evenly across the state. As you go further from the coast, more change is expected than is expected towards the coast. However, if you look at a particular month, like June, you'll note that Northern California is expected to see more change than Southern California. And then in November, just the opposite. So these types of seasonal differences could be really important to someone in agriculture or a industry that relies on seasonality. Using the snowpack tool, you can also use this time slider to look at the projected changes in April snowpack in the Sierras from 1950 through 2099. And again, you can click on any pixel and get a chart showing the information for that particular location. The last tool I'll show here is the Extreme Heat Event tool. Now, all the other tools that we've been looking at use monthly data to populate the charts and visualizations. The Extreme Heat tool is actually using daily data. So the extreme heat day threshold is calculated when you click on a particular pixel, and this is based on the 98th percentile of historic temperature for this area. So for this particular pixel, 102 degrees is historically a very hot time, but it's not unheard of. And so typically you might expect to cross that threshold approximately 4 times a year for this location. And what the projections show moving forward is that threshold might be crossed upwards of 30, 40, 50, 60 times a year. You can also select to look at the temperature minimums or warm nights, which in this case is 64 degrees, and how often that threshold might get crossed in the future. You could look at heat waves, which calculates how many times that threshold might get crossed 5 days or more in a row. And you can even look at the timing of the extreme heat days. That shows a dot on the location between April 1st and October 31st for every time that threshold is crossed. And what you see moving forward is that more extreme heat days are projected earlier in the season and later in the season than were originally forecast in the earlier time periods. All of the data found in CalAdapt is available for download in both raster and tabular formats, and there's a lot more information available in terms of understanding the data that you're looking at. So please visit cal-adapt.org to learn more.